Mic is none. Thanks so much. Okay, so there we go. I was just saying that today is again the day where I release my next video. It's in a minute or so, and so I will have to do all the Twitter and all the crap of publishing it. So I'm gonna just play the new video here on stream for you now while I do the regular publishing in the background. And then if you have also questions, feel free to ask and we can talk a bit about the video. And after that, we head right back into here continuing the series with Ben Eater of the 8-bit computer stuff. Okay, so let me, wrong screen. There we go. And yeah, enjoy this week's video.
We explored how JavaScript Core, the JavaScript engine from WebKit, stores objects and values in memory. Now in this video, I want to learn a bit more about the JIT, the just-in-time compiler. This series on browser exploitation is supported by SSD Secure Disclosure. Check out the description for more information. Simply speaking, the just-in-time compiler compiles JavaScript bytecode, which is executed by the JavaScript virtual machine, into native machine code, like you would compile C code. But there is a bit more fanciness when it comes to JIT in JavaScript Core. So how can we learn about it? I got another tip from Linus to check out some official WebKit resources like this article on the WebKit blog, JavaScript Core CSI, a crash site investigation story. Today I will describe some of these tools that WebKit engineers use by telling the story of how we diagnosed a real bug in the JSC virtual machine. So this is a blog intended for people that would like to contribute to WebKit, and the author shares a lot of very valuable insight into how to debug a crash in order to find the root cause. And this is exactly what we want to know as a security researcher as well. For example, it describes how to create an address sanitizer build of WebKit in order to catch possible heap overflows or use after free issues that for normal programs often don't crash right away. But we are currently interested in the JIT stuff, and further into the article we find the following. JSC comes with multiple tiers of execution engines. You might have read about them here. This is an article that introduces the FTL JIT. There are 4 tiers. Tier 1, the LLint interpreter. Tier 2, the baseline JIT compiler. Tier 3, the DFG JIT. And Tier 4, the FTL JIT. So Tier 1 is the regular interpreter. That's the basic JavaScript virtual machine. We can have a quick look into the low-level interpreter CPP source file, which contains the interpreter loop. So it simply loops over the JavaScript bytecode and then executes each instruction. So now when a function is called a lot, it can become hot. That is the term describing that it's executing a lot. And then JavaScript Core might decide to JIT the function with the first tier, the baseline JIT. And in the corresponding JIT.cpp file, we can get again some additional information. When the LLint determines it wants to do OSR entry into the baseline JIT in a loop, it will pass in the bytecode offset it was executing at when it kicked off our compilation. We only need to compile code for anything reachable from that bytecode offset. OSR, on stack replacement, is basically where you can switch on the fly to the compiled code. It's still very compatible, so to say, with the bytecode, as there hasn't been any optimization yet. From the introducing the WebKit FTL JIT, we can also read, the first execution of any function always starts in the interpreter tier. As soon as any statement in the function executes more than 100 times, or the function is called more than 6 times, whichever comes first, execution is diverted into code compiled by the baseline JIT. This eliminates some of the interpreter's overhead, but lacks any serious compiler optimization. Once any statement executes more than 1,000 times in baseline code, or the baseline function is invoked more than 66 times, we divert execution again to the DFG JIT. DFG stands for Data Flow Graph, so that kind of already reveals a bit what that step is about. The article also has a nice picture describing the DFG pipeline. The DFG starts by converting bytecode into the DFG CPS form. CPS stands for Continuation Passing Style, which means your code doesn't use returns but instead continues and passes on to the next function. If you have ever done some Node.js Express development, I think you can imagine it like the next function. So this form reveals data flow relationships between variables and temporaries. Then profiling information is used to infer guesses about types, and those guesses are used to insert a minimal set of type checks. Traditional compiler optimization follow. The compiler finishes by generating machine code directly from the data flow graph. So here it starts to get interesting. The JIT compiler guesses types, and if the JIT believes types don't change, the JIT can decide to remove certain checks, which of course can speed up the code dramatically if it's a function that is called a lot. But that is not all. After the DFG JIT, there is another JIT, the FTL, faster than light. When this tier was first introduced, it used the known compiler backend LLVM to apply much more typical compiler optimizations. The FTL JIT is designed to bring aggressive C-like optimizations to JavaScript. At some point, LLVM got replaced by B3, but the idea is the same, and the JIT compiler might even make more assumptions on the code. But let's look at this a bit more practically. This is again where the article about the crash investigation is excellent. It introduces several environment variables that can be used to control the behavior of the JIT and enable debugging output. For example, we could use JSC use JIT to disable the JIT entirely, or use JSC use FTL JIT to only disable FTL, the last tier. Or we can disable threads that do JIT in parallel, or we can report and print every time when any JIT does optimization. So in LLDB I set the environment variable to turn everything on and then restart JSC. This already causes some JIT optimization debug prints. Looking at the function names that were JITted, it looks like things like jar, add, ABS, etc. have already been optimized. But now we want to JIT our own function. So here's a liveoverflow function that takes a simple number as parameter, then prepares a result variable and loops from I equals to 0 to n and sums it up in a result. Simple. Next we have to make the function hot. We can do this with a simple loop calling that function. Let's start with only 4 executions. It shows some output, but not what we want. Also, executing it 10 times in a loop doesn't do anything. But calling it a few more times, we will get the baseline JIT. Here is a compiled assembly code equivalent of the JavaScript function. Let's try to trigger an even more aggressive JIT. Let's increase the loop. And boom, DFG JIT. And now let's go totally crazy. Adjust the loop, FTL JIT, boom. There's also so much more output, but to be honest, no clue what that all means. But the important part is just that we have learned about various debugging methods and tricks to dig deeper. Now you know a bit more about the JIT compilers. From last video, you also know how JavaScript objects, arrays, and values are represented in memory. Now consider the following idea. If the JIT compiler guesses and assumes types in the code, and removes checks and, for example, just simply moves from a certain memory offset, could that be abused? Just hypothetically, let's say JITted code expects a JavaScript array with doubles and directly acts on these values. The JIT compiler then optimizes all the checks away, but then you find a way to replace one entry of the array with an object. Now an object would be placed as a pointer into that array. So if JITted code has no checks and, for example, returns the first entry of this array, it would return that pointer as a double, right? That would be pretty bad. And that's actually one of the typical browser vulnerability patterns, and we will see that in action soon. But how does the JIT try to prevent things like this from happening? Well, it turns out that the developers try to model every function that has an effect on the assumptions of the JIT compiler. So if there is anything that could change the layout of that array, for example when an object is placed into a double array, then such a function should be marked dangerous. Let me read you a quick excerpt from this CDI article about inverting your assumptions, a guide to JIT comparisons. Here they write, the way to state that an operation is potentially dangerous to prevent later optimizations is to call a function called clobberWorld, which, among other things, will break all assumptions about the types of all arrays within the graph. So the JavaScript engine tries to mark everything that could have potential side effects by calling clobberWorld. Side effects could be things like we just thought about, like changing the type of a value, and something else didn't expect that change. So here's the function clobberWorld implemented in the DFG JIT part. This will call clobber structures, which will set structure clobber state to structures are clobbered. So side effects that the JIT has to be very careful about are obviously things where, for example, the structure of an object changes. Let's say the JIT optimizes accessing a property X on an object, and suddenly you remove that. it has to be marked that the structure changed so that jittered code can be discarded. Otherwise, you get memory corruptions if you reuse that jittered function. But that's enough for now. Next video, we move on to Linus's exploit abusing such a case. Thanks again to SSD Secure Disclosure for supporting this series. Check out their website and learn more about the SSD Vulnerability Disclosure Program at ssddisclosure.com.
Yeah, that was this week's video. Next week, we finally look at the exploit from Linus. Now we know the basics. We know how like objects and values look like in memory, how we can debug this with the debugger, and we have somewhat of a basic understanding of the JIT compiler and how it optimizes codes, and already an idea for an attack, like what if we can somehow abuse these assumptions that the JIT compiler has. I hope it's clear in that video that I have no clue what I'm talking about. This is, as I explained in the very first episode or the start of the series, that it's me learning as well, right? So I might have said some wrong things in this video as well. It's kind of like my understanding of it, and I think it's a good basis to learn more. But yeah, take it with a grain of salt. I hope that is clear. I don't want to pretend I know what I'm talking about. But yeah, I'm excited. As I said, next video we will start like looking at Linus's exploit, and we will be able to step through it one by one. Okay, yeah. So this was this week's video. Okay, so recap about yesterday. So yesterday I started this stream. Basically, what I want to do is I want to build the 8-bit computer from Ben Eater.
So ever since I
Yeah, it's this one here, or a version of this, and Ben Eater has this long series. He has done this over like 2 years or something like this, and so basically I want to follow that along and build that. So yesterday we started with the first video, which was the introduction to the 555 timer, and if you take a look here at at this here, this is what we built yesterday. It's basically the same thing. Let me get that on the big view. So yeah, you can see here that we have the IC here, and I mean later in the video he adds the what's it called? The resistor with the turning thing. So basically this here. Yeah. Let me quickly show that off to you, and what I've done since yesterday, I picked up because we made a mess yesterday. The stream video on demand should still be available on Twitch, and I will also upload it on YouTube, but not the main channel because I don't want to spam the main I assume people would just get mad if I would do that. I would love to upload it there, but I feel like people would get mad. So I've actually created already a second channel and started uploading, but I need to fix up some stuff. I've also decided to do some kind of highlights, just a very rough cut of the stream to condense like 30 minutes into like 20 minutes or so. So as a recap to watch or something like that. But I will share that at some later point. Yeah. Okay, so let me show you here. So yeah, we built that yesterday, and I've also here brought this over and set up. Here again we have the oscilloscope, and I also brought the power supply over. So now we have a proper 5-volt power supply here. And so when we turn that on and we look here, we can see the LED blinking. So this chip, the 555, is a timer chip that you can configure through capacitors and resistors to control how this chip will basically create the clock. It's a square wave. We looked at this yesterday with the oscilloscope. You can watch the video; it's in there as well. And yeah, and so at the end of the last stream, we also added here this. What is it called again? What is this resistor called when you can turn it? Anyway, you know, you can select a range of resistor values here. You can see that we can affect how quickly the LED blinks if we change the resistor value. So I find this fascinating that you have these electronic components that do something. In this case, it's creating like a square wave, basically a clock signal. And I think it's so, coming from a software background where we have functions where we can pass in parameters and those parameters affect the functions, or we have config variables that change the behavior of our software. Thinking that this is also the case in hardware was somewhat, I don't know, mind-blowing to me. And so the way how you configure basically this chip is with certain resistor values or certain capacitor values, because depending on the capacitor, it can charge up, it needs longer to charge up or faster to charge up, and the resistors also control how fast these capacitors are charged or not, how much it's basically let through. And if you have a variable resistor like this, you can obviously change the resistor value, which affects then the speed of the square wave. I think this is so fascinating that you can like configure and stuff hardware values as well. Are you planning to do a format like scanline? I wish. I have no clue about electronics. She obviously has, you know, way more experience, and I'm sure you can learn a lot more. The format I'm doing here is basically watch these videos and try to build that computer. So it won't be as cool as scanline with cool reverse engineering or makeup projects that where she actually does cool stuff. Electronics is just very low-level functional programming. Yeah, I can see that. It makes sense. Yeah. Okay. Right. Was there anything else? No, I think that was it. That's all I did yesterday. Any questions so far? Or shall we just head into the next video, the second video? Okay. I turned up the volume of the laptop. Let me know if the volume of the video is like too high compared to my voice, or how I need to adjust. I still need to fine tune all these settings. All right, let's start with the next part. Oh.
So in the last video, we used a 555 timer here to build this little clock circuit. And so we have our
test, my voice in between.
Clock output on pin 3 of the 555 timer. And we can control the speed using this potentiometer. And so that's great, but there might be times when we want to manually control the clock. And we want to be able to just push a button each time we want the clock to advance or we want our computer to advance one clock tick. And so you might think, well, that's pretty easy. We just hook a button up. And so we have, you know, this output here of the button is pulled to ground through this resistor normally. But then when we push the button, it connects it to our 5-volt supply here. And so push the button, it comes on. And so we can manually pulse the clock like that. And you might think, well, that works pretty well. And that's almost true. And in fact, you might be able to use this and you might be fine with it, depending on the button that you have. What happens is inside that button, when you push it, there are 2 metal contacts that come together to close the circuit. And sometimes what will happen when you push the button is those contacts will bounce. And so it'll close and then bounce and then close again. Or maybe it'll bounce a couple times. And so what happens is when you push that button, you actually get a couple quick pulses. And if that's hooked up to, you know, the clock of our computer and we push that button, we could actually trigger a couple clock pulses when we only meant to trigger one. And that could be really frustrating if you've got, you know, some issue that you're trying to debug in the computer and you've spent a couple minutes getting it all set up just perfectly, and you're right at that point where the next clock pulse is where you're going to figure out what's wrong with it. And you push this button to get a clock pulse, and you get 3 clock pulses, and it goes right past the problem you're trying to find. That could be really frustrating. So what we want to do is we want to figure out a way to get rid of that avoid that bouncing. And you guessed it, we can do that with our friend the 555 timer. But first I hooked up the oscilloscope just to take a look at the switch here. And so when we push the switch, you can see this is what we'd expect, right? It transitions from off to on. But if we try this a few times, we might see some different stuff.
Well, there we go.
Oh, there's something. Yeah, look at that. So that definitely bounced right there. And so that's not good. You don't want that because that would look like 1, 2, 3 potentially clock pulses when you only push the button once. So you definitely want to get rid of that. And so this now is a 555 circuit that is going to help us with this switch bouncing problem. And so, well, before we get into it, let's just try it out. Let's push the button and see what happens. Push the button, the light comes on, and then a little while later the light turns off. And importantly, what happens if we push the button multiple times, the light only comes on once, and that's what we want. And this is called a debouncing circuit, and there's a lot of other ways to build debouncing circuits, but I'm using the 555 timer just because I think it's a fun chip to play with. And so the timer here that's controlling how long this stays on when you push the button is controlled by the resistor and capacitor over here. And so you remember before we had 2 resistors and a capacitor that were controlling the pulsing. Here we just have 1 resistor and a capacitor, and we'll go into more about how it works. But basically, the time that the LED stays on is just, you pretty much multiply the value of the resistor times the value of the capacitor. And so this is a 1 megohm resistor, and this is it's a 2 microfarad capacitor. It says 1 MFD on it, but apparently these are 2 microfarads. But anyway, the nice thing about this is 1 mega ohm is 10 to the 6th, and microfarads are 10 to the minus 6. So the math works out really easily here, so that a 2 microfarad capacitor, when you multiply it together, you just get 2. And so that gives us a 2-second delay. And sure enough, we push the button, and the LED stays on for 2 seconds, which I guess is further confirmation that this 1 MFD capacitor is really 2 microfarads. Anyway, so 2 seconds is kind of long for what we want. So what we could do is we could put in a 0.1 microfarad capacitor instead of this 2 microfarad capacitor. And if we stick that 0.1 microfarad capacitor in there, that's going to give us 0.1 seconds because we're multiplying it by this 1 megohm resistor. So now it stays on for 0.1 seconds. No matter how quickly I push it, it's kind of hard to tell. But that's what we want. We want it to pretty much follow what we're doing when we push the button. But we critically are getting rid of those bounces. And so as long as any bounces that happen within the first 100 milliseconds or 0.1 seconds, we've gotten rid of. And that's what we want. And so I understand how this works. Let's look again at our circuit diagram. And I've got the 555 timer here, the guts of it exposed here. But the green bits out here are our circuit. And of course we have an LED hopefully the output I didn't draw. But and of course we're just looking at this lower half here. This is what we built in the last video. And so we've got our resistor here, which is our 1 meg ohm resistor. Then we have our capacitor, which is a 0.1 microfarad capacitor. And then, over here I've got the button hooked up. And if you look at how this is hooked up, the button is connected between ground and pin 2. And then it's also from pin 2, you can see we've got a 1K pull-up resistor. Basically what that does is it ensures that pin 2 is normally connected to 5 volts, but then when we push the button, it connects it to ground, and then pin 2 goes to 0 volts. So just like before, we've got this voltage divider network going on inside the 555 timer, and so we've got 5 volts up here, and then we've got 3.3 volts here at this first point, and then we've got 1.667 volts here at the second point, and then of course ground is at 0 volts. And so that's just a voltage divider, resistor voltage divider. We've got 1/3 of our voltage, 2/3 of our voltage, and then up here is our full voltage. And so we can see right now, our output is off. The LED is off. So if our output is off, then that must mean that the Q output of this SR latch is off, and so the inverted Q output must be on. And so if that's on, then that's going to be putting current into the base of this transistor. And so this transistor will switch on and will be discharging, or will be pulling current through this transistor. And so, in this state right now, current is flowing, from our voltage source through the transistor to ground. And if this capacitor had any charge on it, that would also be, discharging to ground. And so this capacitor doesn't have any charge on it, and so our threshold is at 0. And of course, 0 is not above 3.3, and so this is going to be off. And then this down here is 5 volts, right? So it's, trigger pin 2 is 5 volts, and 5 volts is not below 1.6 volts, so this is also off. So both of our S and our R inputs into our SR latch are off right now. And so somehow this latch is just latched into this state where it's off. But what happens when we push the button? When we push the button, we now pull this trigger low. We pull this to 0 volts. And so 0 volts is definitely below 1.6 volts. And so this comparator here turns on, and that triggers the set of our SR latch. And so that turns the output on. And so sure enough, we push the button, the output comes on. So no surprise there. But the other thing that happens is when that output comes on, this turns off. And so we're no longer, pulling current through this transistor here. And we're no longer discharging this capacitor. So instead, we're charging the capacitor. And we're charging the capacitor through this resistor. And so this capacitor is going to charge. It's going to start to charge. And eventually, it's going to get above 3.3 volts. And so when the capacitor charges to above 3.3 volts, now the reset is going to be triggered. This comparator is going to turn on. It's going to trigger the reset. And that's going to turn off our output. And it's going to turn on our inverted output here, our inverse Q. And that's going to push us back into this state where we're now discharging the capacitor. And now there's no resistor between this capacitor. Remember in the circuit before we had another resistor in here, but there's no resistor here. So this capacitor is going to discharge immediately. And so it's just going to drop right back down to 0 volts. Which of course is going to immediately turn off this comparator, right? Because 0 volts is certainly not going to be above 3.3, and so this comparator is going to turn off, and we're not going to be triggering this reset anymore. But if we're not pushing the button, we're not triggering our set anymore either. And so the latch is just going to stay in its latch state, and our output will be off. So if we're looking at what our output did, as soon as we hit this trigger, our output comes on, right? Because we set the latch, and then it stays on while the capacitor charges up. But then once the capacitor gets to the 3.3 volts, boom, our output goes off, and it just stays off. And it stays off until we hit that trigger again, until we push the button again. And so you might hear this referred to as a monostable mode of the 555 timer, because it's called monostable because there's one state where it's stable, and then if you push this button, it goes into this other state where it's not stable, where it's going to, eventually this capacitor will charge and then it'll drop out of that state. Whereas what we did in the last video with this is called an astable multivibrator, or astable mode for the 555, because it doesn't have a stable state. It's constantly altering between two states, on and off. So you might hear those terms, monostable and astable. So to take a look at that in action, I've hooked it up to the scope here, and I've also gone ahead and put that 2 microfarad capacitor in there again, just so we get that nice slow 2-second pulse there. So if we fire up the oscilloscope here, push the button, you can see the output goes immediately high, and then you can watch the capacitor charge.
It's so cool.
And then boom, as soon as it hits that 3.3 volts. So let's see, 1, 2, 3.3, yeah, 3.3 volts, capacitor gets there, and boom, that discharge pin flips, and the capacitor just instantly discharges, and then of course our output turns off then. And so you can see any bouncing that the switch is doing in here, doesn't matter, our output's already high, we've got that latch that's latched it high, and then as long as this capacitor will just charge away, and then boom, turns off. So I've got that 0.1 microfarad capacitor back in there with our 1 meg resistor. I think that's what I'm going to go with. And just like before, we've got that control voltage pin, which is pin 5 here, that we're not using, and that's just kind of tied into here. And again, the data sheet recommends putting a 0.01 microfarad capacitor between that and ground. So I'll go ahead and add that in there, and that's just for that noise reduction that we saw in the last video. So good practice, put it there. And then the other good practice is pin 4. Also not using that. That's a reset pin that kind of ties right into the reset of the SR latch, and it's an inverted reset. So normally it should be at 5 volts, and then bringing it to 0 volts forces this to reset regardless of what's going on over here. Just kind of override things. So we'll tie that to 5 volts there just to prevent that from accidentally tripping or anything like that. And I think that'll do it. So now we've got our timer here. So we've got that, and we can adjust the speed. So we saw that in the last video, and go really fast or really slow. And if we don't want to use that, we've got a manual clock pulse here. So now we just need to come up with some way to switch between the two of those, and we'll look at that in the next video. So in the last 2 videos, we used these 555 timers to build an A-state.
Okay, cool. First of all, let me answer, or let's talk about quickly what was written in chat about the science and technology category. And also Zoding is also streaming there, so definitely follow him as well. I have streamed before, like when I did the web development stuff. I did that in science and technology, and I agree with you, that totally makes sense. However, I'm just experimenting. The just chatting category is obviously massive. It's like a huge part of Twitch. I want to just experiment with that. I don't know. I don't think a lot of people like go into science and technology and find a view. There's, I think, a very small group, and then just chatting are a lot. And so my hope is that I maybe can catch a few people who were not even considering to do programming or electronics, and they stumble randomly then into such a stream, and then they might be interested in it. So rather than the people who are already totally into programming and are looking for that. So that's kind of what I'm thinking. I don't know. I don't really care, to be honest. Yeah, I think absolutely for like to keep the site clean, I understand that it should go into science and technology. Let's see if Twitch like complains that like it wouldn't belong into just chatting or something like that. But I don't know. Let's see. I don't have strong feelings either way. It's just like, I don't know. I figured I'd just try to see what just chatting is doing. So far, I don't see a difference in terms of like, I mean, it just was one stream yesterday, so I didn't notice anything different than when I streamed before. Okay, second thing, I'm not sure about like the building thing now, so I think I want to just quickly skip through the next video. Or has anybody built this or gone through the videos before? Because I'm wondering, is he just like still explaining the 555, or is he actually building the clock module already? So because right now the thing that we have built here looks pretty shitty, and he has it way better arranged. It looks way cleaner. So if this is actually how it will stay, and this is actually how the clock module will look like, then I would want to redo this and obviously also do the debouncing of the button. But if he would do a completely different clock module later on, I wouldn't want to build the debouncing button or something like this. So I'm not sure about this. So let me quickly just maybe, let's see. Here he's doing the bus arc. So here's the bus architecture video. Before that, he explains the SR, the different latches or flip-flops. And then there's the clock video, which is in 2 videos. So let's just quickly
in the last couple videos
compare. Okay, no, it looks like, I guess that is the whole clock module. Yeah, okay, then let's do this properly. Then let's also build the button. Then we can also measure this again. We can replicate what Benito was showing in the video. That sounds great. Then let's do that.
So in the last video.
Okay. Right. So let's do this properly. I guess is that blue wire? blue and red wire. Let me gather all the materials that we need to rebuild this properly. So we got the wire here. Let me show you this screen. I think I knocked this yesterday a little bit. Whatever. Oh, thanks for the cheer. Okay, so we got the wire. We need the capacitor stuff. Let's take this. Then we have here the capacitors. We need. So this LED is not so great. So I have here in this box is everything that I ordered from the part list from Ben Eater. You can find the part list on his website. Can't get over how many breadboards this is. It's crazy. Okay, anyway, let me find. So I have a red-green weakness. Is that a yellow LED or is it a green LED that he was using there? Here are the 555 chips. It's green yellowish. Okay. It's yellow. Okay. Okay. Yeah, that makes sense because I ordered also way more yellow than I ordered green, so that makes sense, I guess. What else am I looking for? We need a wire cutter. Okay. Oh yeah, and so he has this very clean blue, like and if you look at his thing, the blue variable resistor, and I have like this massive kind of thing that is flopping around. Let me check my other electronic supply. I kind of hope that I have a better one, but I'm not sure if it has the correct resistor values. Let's see. I think I have some in here, but they are all shitty like that. Maybe I need to look again in the store. Yeah, okay. So let's measure this one here, and then I have this one here. These are all kind of like, they're not great, but we could create a small like base plate or something, or like solder it somehow onto something. I mean, if somebody is bored, you could also, I think it's a, I forgot the capacitor. If somebody's bored, you can search in a German store and then I order a different one. Oh, buttons. We need buttons. Buttons. Oops, what kind of buttons did I buy? This is terrible. I do have short ones. I thought I paid attention to that, but I guess I didn't. It's just about the size of the bar. You can just cut it. Yeah. I thought about that too. I'm not sure if I think I have a saw. I mean, we could just like cut it short or something. But it's also like how it's oriented. It's like very flimsy. I mean, I can bend these downwards so that I can kind of stick it down like that. I think that is what I would want to do. I am not sure if that's then still like kind of stable enough, or I don't know. We will try that in a second. Okay, and then I have buttons here. How many do we need? First one, I guess. Okay. Yes, so I have here the multimeter that I quickly want to... I guess I could just look it up in the parts list again, what kind of resistor that was. Here's the part list. A potentiometer, that was the name for the variable resistor. So that was one meg. Okay, so let's see. So I'm measuring here. Oh. Okay, that is something smaller. What is it? 50K? I guess. What is this? That's also 50K. And this one was. Come on. Yeah, 1 meg. 20. Yeah, that's all I had, right? All right. Okay. Let's see. Let's unplug this for now. Unplug this. Put this up here. I need Okay, yeah, let's build this circuit here again first, properly, nicely cut everything. He's building that really tight up there. I mean, this one isn't, I guess we can shorten it a little bit. Could someone or have just post pin a short roadmap for this task, please? What do you mean with that? Like what exactly I'm doing right now? Because basically I'm doing exactly what this video is about here that you can see up there, which is part 2 of the Benito clock. Or do you mean what the overall goal, what I'm working on, what this project is all about? Is that what you want to know? You can find in the description of the stream, I think a link to that playlist that I'm working on, I think. Okay, yeah, so basically Ben Eater has made this series where he was building an 8-bit computer. You can find the link, I think, in the stream description. And basically I want to build the same. It seems like a really cool project to learn. So I don't know, like I'm an amateur in electronics. It seems like a cool project to learn more about it. And so we are following along his videos that he made. I've ordered all the parts and we are now on the second video right now. So yesterday we had one stream about the first video, and now we do the second one. Okay, thanks for the cheer. You can also find the VOD from yesterday in the on Twitch. Oh no, you're not bothering. I think I should maybe need like a command or something, like exclamation mark topic or something like that. That just puts it out. Okay, so that looks a bit nicer, I guess. Now I'm like really not sure. Like it's good enough, right? But I want this to look really nice. So I'm wondering, because I made it a bit too short and you see it's like angled, it's not properly rectangular. Also, is this blue or green that he was using there? I can't, it's more green, right? I think it's more green. Maybe I do that again. I mean, I need to practice doing this properly anyway. So maybe let's do this again and let's try what is a good method to make this exactly the length that you want. So yeah, how do you do this? So you want it in here. Maybe you keep a little bit to bend, like that. Then comes the first bend here. Like that. Up until here. And then here comes the second bend, like that. Okay. And then we go up to the second pin until here and a little bit more for the pin. So we cut it here. Maybe OCD. It's not really OCD. Like I don't think I'm like really obsessed with perfectionism or anything like that. If I would be that, I would do a lot of things. I don't think I could have a YouTube channel. I would be obsessing way too much. But I'm very much a person who can. I think I can recognize when it's like good enough. Okay, so stripping it here. And here. Yeah, this looks perfect. Cool, this looks way better. Okay, how much OCD should I do now? Maybe this one bend here could be a bit stronger. Cool. Excellent. Okay, now we need so how do I deal now with the wait, I needed to also think about, so his clock module was pretty full at the end. If we compared it to the state here later here in the video. Like with all these chips that are coming afterwards here. He has only 4 free before the chip comes, and I'm 5 here already, and this is so big. On the other hand, actually we don't need the 3rd pin of this one here, so maybe I'm just overextending here a little bit. But then we can't have this very pretty like wiring kind of around this. It's so massive. Okay, let's test this. What if I like bend? Oh, what's this? Okay, so I'm bending this down now like this, and then and let's move that also now to 4. That. And then we can, so this goes again. Okay. Like that. I guess that looks kind of nice. That's fine. Oh, it's pretty solid there as well. I mean, the problem is still kind of that there's kind of not enough space. He has he has a resistor going up there and another wire, which I don't have the space for. And if I put it in here like that I have the space, now it's overextending. Now the OCD is kicking in. Okay, I will do it like this, and I will try to find a replacement at some point for these. They look crap. Like, they are just, it's okay for now. So what do we have here? I also have, if it's working, it's not always working. Ah, there it is, microscope. So which color is that? Brown, black, red, gold. Okay, so this goes over to the 7th pin. Goes in here. Did he get smaller resistors? Because like they are like super short. Oh no, I think he just bent it a bit more. You're still wearing the CC wristband? Yeah, it's called vaccination. Okay, this is not holding. Okay, I think I also need to learn how long I have to make these. So this is way too, I made them too short. I need to make the legs longer than that. Also, I mean, so I told myself I'm not gonna wear the glittery one throughout the year, but I was so lazy I haven't even cut the long part off. Like, that is annoying me like hell, but I was too lazy to even do that. Okay, so I think it was this one here. Gold, red, black, brown. Yeah, that matches. I wonder if you are able to wire this as clean as Ben's videos. Mine looked like shit after a few hours. Oh, do you have pictures of yours? I would like to see that. And yeah, that's also my worry. That's maybe why I'm a little bit careful already at the start, because I feel like, oh, I should make these things way longer. Wow, they go deep. Maybe I've even made these too short. I'm actually not sure. Okay, so this one goes into the second one. Okay, and I need to put this even further once because there's not enough space there. You didn't finish it, stopped after the first two registers. Oh, that's a bummer. But yeah, Ben's one looked so nice. I in my head I wanna put it into like put it onto a wood or something on a plate and then hang it at the wall. That would be so cool. And then maybe like that's the ultimate dream. Like if I actually manage to finish this and build the extensions of like having more memory and stuff like this, I wanna build a module that takes in like or at least a serial that just writes it into a register or something like that, like using an Arduino that just places what's coming out of serial into a register or something like this, and then having chat messages or donations or something like this as inputs to the thing, and it can be controlled in a way. That would be so cool. Oh, hey Sato. Yes and no, not really. Let me first. Here, let me show you. I actually, like, it was actually in a good state already. So I did this here. Oh, crap, wait. So I did this here off stream. I didn't change any code. This is literally just deploying it basically to AWS and stuff. And I populated it with some data. So this is as much as we got it on stream. So it's online on hacking.app right now. I just haven't announced it yet because there's not really much there. And you can already like explore a couple of videos. But like I said, there's like not much there yet. I made pictures for a lot of stuff already. But again, not for everything. Like here is nothing. So yeah, and there are a couple of bugs. I have written down a couple of to-dos on mobile. There's a weird issue with like the border, and for example, when you go into browsers, it's like, you know, you have all this space here in between. It should all be just left justified basically. So yeah, there are a few things that have to be fixed before I want to like really publicize it or something like this. But yeah, feel free to use it already. And it worked great. Like so how I do it right now, the Django application is deployed on a server that is only reachable from a VPN, and I can manage it there. And when I want to deploy it, I basically just run the Django distill command to do the static site generation, download the files from the server, and push them to AWS. And that's what you see here. So it's, yeah, it works. So we did develop this on stream, this website and stuff. Still have all the recordings. I will probably also upload those recordings on this second channel that I mentioned at the start of the stream that I will create for the stream archive and stuff like that. Yeah. Oh no, you're not distracting. You know, conversation is content. Otherwise I'm just staring at this and just doing wiring here. That's also pretty boring. I think it's really surprising. You're not the first person asking about it, so it's kind of cool that like people have watched it back when I was working on this a couple of months ago and are now interested in the state. So it's pretty cool. Okay, so next resistor. You know, I already did this wrong. I should have put this into like a proper thing to hold it. Oh, is that the same one? No, that was a 1K, right? If I remember correctly from the stream. Oh yeah, that is a 1K here. Is that a 1K? Yeah, that's a 1K. In circuit measurement. Yeah, okay, we're also 1K. Okay, yeah, so this is also 1K. And that goes from 2 here from here to second up here. Okay. Anybody experience with like bending kind of stuff like this? Like, is there like a cool tool, or because this one is like not fine enough. Like when I close this, then there are like gaps. As you can see, like I can't really hold it too tight to properly bend. And I have this one here, but it has like plastic tips, so it's also like not strong enough for properly as like a corner to bend. What's a good maybe I could use like a corner like this here. Maybe that's actually a good usage. Sorry, here like the corner like this maybe. Metal tweezers. Yeah, I'm not sure if I have I might have somewhere. Spitzzange. Yeah, okay. I think these are things that I might have to buy. Oh, thanks for the sub, Saito. Yeah, now that I have like the last time I streamed was I think last year in December or something. So since the start of the year, if you haven't heard yet, I finally registered a business, so I can finally also make use of like subscriptions and all that and add money and stuff like that. So now I can like claim income. Steal one from my girlfriend. Yeah, if I don't know where her stuff is. Probably in the bathroom, I guess. Oh, thanks for the sub, Knowles. All right. Then what do we do next? I guess this wire up there. I think we can. So we have wire going up there. Oh, I'm such an idiot. I'm such an idiot. So I'm an idiot because I did the resistor exactly how Ben Eater did, but obviously the pinout of my potentiometer is different. Fuck. If I put it down and I don't have space. Is there possibility to do some pen testing today? Yeah, for sure, we can do some pen testing. I can't find my proper pen testing gear right now. I don't know where my proper pen testing gear is, but so I only got like this pencil right now, which is a bit light, so it's not as good. So yeah, this pen is way too light. With a lot of practice, it still works, but it doesn't look as smooth and it's not as well controllable as other pens. Oh, thanks for the sub, Bang Pal. Here's your attempt. Wait, how do I get this? Damn, I'm good. Oh wait, you didn't see. I guessed the URL. Ah crap, now I don't see the... Okay, wait, how do I get... I guess I just type it really quick. The problem is I have the chat on a different computer than the one that is shown on stream. There we go. That's the clock module here. Yeah. Yeah. That's also my fear. I mean, like, it doesn't look as clean as Ben Eater's, obviously, but this is how I imagine mine to also look like. Or that's kind of like... I think this is what happens when you just do it, right? So I don't understand the magic that Ben Eater is doing. It starts with simple stuff, like this long yellow line, for example, you know, is not perfectly straight and stuff like this. How do you make it as nice as Ben Eater's stuff? I don't understand. But it worked? Nice. Lost interest, or were you just not satisfied with your own result, or just other stuff? Was it too much work? I also feel like you tried clipping the wires and bending them in a nice way, but it looks like it is. Yeah. That's also how I imagine it to go for me. But I hope that and I also would think if I would do it by myself, I might also give up. Like as soon as I have, like I could do it for a couple of days, and then real life would catch up with me, and I would have other responsibilities to take care of, and then I would lose interest. I have a very obsessive kind of like personality, so if I get into stuff, I really get into stuff, and then I also quickly lose interest again and move on to something else. And YouTube has been an amazing incentive for me to keep sticking to stuff, and it has worked out so well for me. It still kind of amazes me that I'm able to consistently do YouTube. And so I mentioned it yesterday in the stream already. I hope that Twitch also helps me with a proper schedule, and because my life is like in a complete screwed up schedule, and also sticking to this. Like if I have like the pressure and the stuff to do this on stream and tell myself to finish this on stream, I hope this will provide enough pressure and motivation. You still have all the parts, even the memory for the ALU. Bought that from China. Maybe we'll pick it up again one day. Oh, that reminds me, I also had to order it from China, and it hasn't arrived yet. So, I mean, I guess I'm glad that we are not there yet. Need to check what the delivery status is. Okay. I think we can reuse this piece of wire from earlier for going up there. So this goes, okay. So from here and then thanks for the sub, Procker. Are you born in 91? If that's the case, you are my age. How much were all the parts? That's a good question. So on the Beneder website, you find the parts list, where he also listed the price. So it's about $250 to $300. You can also buy it. He sells kits, which I would have totally done if I was in the US. But the shipping to, like, it's $270 directly from Beneder, which just saves you also a lot of time and stuff like this. But the shipping was $80, and $80 of $270 is quite a major thing. And then also getting that from the US would mean that it might get through duty, and then I would have to pay the VAT on the import as well. And so I didn't want to run that risk, so I just ordered all the parts myself. I've done a spreadsheet for myself where I ordered the parts in Germany, or I actually ordered also still from the US some things, but through a proper shop that handles the import things, mainly for the breadboards, because he uses good quality breadboards. Yeah, and so I came to 240 euros was my order, everything. I might clean up the spreadsheet that I have and share that at some point too. Always getting scammed on shipping. Well, I wouldn't call it scammed. I think shipping is super expensive. I mean, it surprises me sometimes how cheap shipping is. I mean, if you think that it has to be transported through all these various places and then put on a plane and then flying over and then getting distributed to my house, I don't know, that seems like insane for $80 actually. But yeah. But yeah, it's just too much then, like, you know, for this project, so I decided to just order the parts in Germany. For $80 you can transport yourself from here to Mallorca and back. Yeah, well, Mallorca is also still Germany, so, you know, that's cheaper, I know. Okay, so we've done that. Then we need a red wire over there, which is just that. the weird part of Germany where everybody's wasted. Yeah. I have not been there since I was a child. Okay. How's the weather with you guys? It's so warm here, and the problem is my room is like the windows are exposed to the sun all day long, and oh my gosh, this room is heating up so much. I have an AC, like an AC unit for that, but the problem is if I would turn that on, that would be like crazy for the stream. So I can't use it during the stream. Let me check. So in here in my room, it's right now 31 degrees. And outside it's 28. I guess it's time to open the window. Oh, sorry, to the breadboard. Yeah, you're right. Sorry, still getting used to all of this. Thanks. Also, I have this weather station measuring app, so it measures the CO2 parts per million in this room here, and I think it's also time to open the window. Okay, then I need, because I screwed up here, you know, like the pin out of the resistor. I need like a very tiny bridge as a temporary solution for until I like get a proper like replacement. There we go. Doesn't look too great, but I mean this whole thing looks shitty right now. Now you also have the outside noise. Oh my gosh, sorry for that. Okay, so then we need these ones were the 1 microfarad, right? I forgot. Yeah. Okay, so not these ones here. Your PC is making work. Is the warmest, is Berlin the warmest place in Germany right now? No clue. Not a good time of the year for fuzzing. That's why the Russians are so good at IT security. Their fuzzers can run at crazy speeds with natural cooling. So these ones here were also one micro. I forgot he's using, so he has like two different size capacitors here. This big one and small one. I forgot the values of those. Oh, what are those? Um, 10 nanofarad. Oh, I'm not logged in. Oh, but yeah, that's my viral video. That is that video that gets recommended to everyone. That's completely skewing my statistics. The video that makes my channel look like it's a big channel, even though it's just this one video. It still drives like a third of my monthly views. Like that single video is worth a third of my like almost 200 videos or so. Oh, I don't know how many I made. 100 videos? I don't know. Wait, why is this not measuring? Didn't we measure this yesterday? Ah, sorry, the view. I think I missed a chance on a clickbaity title. I also thought it's a kind of a mundane one, but this video is clickbait. Like that video has a great click-through rate. It's not viral because people share it or anything. It's viral because the YouTube algorithm deemed it to be, it kept people on the site and it had a great watch time and people were clicking on it over other things they clicked on. So maybe it's a thumbnail and not the title or anything, but one of these things must be the clickbait thing which caused YouTube to recommend it to everybody. It's like the views coming from Reddit or any other sites sharing it are unimportant. They are so small compared to it's all from YouTube recommending it. Okay, but why can I not measure my capacitors anymore? You didn't. I'm sorry. Wait. Oh, I also need to. I forgot. Actually, wait. I need. There we go. So this is supposed to be a 1 microfarad capacitor, and my thing here doesn't measure it anymore, and it did measure it yesterday. What am I doing wrong? Hey CCC nerd. Am I stupid? Oh, polarity. I'm such an idiot. Was it that? Oh, no, okay. Am I what? This is frustrating. I don't know what I did. Did I break it? That's the only multimeter I have. Okay, so yeah, maybe debug with me here. Did I select the wrong thing? So I put it on 200 micro because it's the only one close in the range. Come on, stupid autofocus. Come on, where's your center camera? Please autofocus. I measured this yesterday, and it should at least, like you see, the 200 comes with comma thing as well, so 0.9 or so should be possible. And this is a 1 microfarad, and it showed up yesterday. I measured it. Like, I'm 95% sure I measured this yesterday. Oh well. Does Benito have a schematic of his stuff? He has somewhere, right? Yeah, I can measure capacity. It has a micro. I also thought polarity. That was the first mistake I realized I was doing, and then I switched it, and it still didn't show up. Okay. The computer's clock is using this video goes into details. There's the schematic. Okay. So let's see. It should be this one here, right? Okay, so we have a... Okay, here, this... Okay. Okay, so we have two 0.1 microfarads on... Why does he have it in parallel? Okay, whatever. Anyway, and then so we also have a 0.5 that was going to 5, and the 1 microfarad was the big one. Okay. So now I need to figure out again. Somebody posted the so is this one here 0.1 microfarad? No, wait, I need a 0.01. My God, what's going on with me? No, I'm not talking about C temperature. Look here. Like here, microfarad. Or am I completely stupid? That is always also a possibility. Come on. This camera is the worst. How can you decide to still focus on the stupid background? Okay, what else would this measure meant to be? M or micro? What would it measure here on this scale? That's the capacitors, no? And I'm 100% sure we measured this yesterday as well. Didn't we? No. Voltage is over here. This is AC voltage, and here's DC voltage. Oh, microampere. That makes sense. Let's forget this happened. Wait, didn't I measure capacity yesterday? Oh my God. This is the good thing with the internet and recording yourself. Can't pretend to be I cannot tell myself like you are wrong, because clearly the evidence is there in the recording that I didn't. Yeah, for ampere, yeah. I'm such an idiot. Unbelievable. Well, this just justifies to buy a Fluke multimeter. The question is just which one I should buy. Or does anybody have a better recommendation for a multimeter? I don't mind to spend. So I don't feel like I want to spend 400 or 500 euros for the big Fluke one, but like 200 euros would be fine for a good multimeter, I think. Can anybody recommend one? Yeah. So the here, this is the 1 microfarad polarized one that is in the schematic here. I mean, it also has the different the polarized capacitor symbol, and then we have the 0.01 microfarad that are all over the place to stabilize these 5.5 chips, and then besides that, we have the 0.1 microfarad, which is just to between, to like clean up the, like as a filter. Is that the term? Yeah, I know that it's printed on this one here. So I wanted to measure the capacitance of these ceramic ones, right? And then it didn't work. So I went back to this one here because here I know that it's 1 microfarad, and that's when I then got confused why this doesn't measure it. Yeah, that was like my test, because from this one I know it's printed on it. But I forgot how to what is that? Is that 0.01? Ten nanofarad is 0.01 microfarad, right? Looks like building a 5.5. Hi, Rise. Yeah, I'm working on, I don't know if you know this, from Ben Eater, building an 8-bit computer, like this series. So we just got started yesterday. We are on the second video right now, and I'm rebuilding the circuit right now here based on that. So we are learning about the 555 timer and all the other stuff. Okay, so cool. So that is great. So these ones are the small ones, and now I need 0.1 microfarad as well. Let's see. Seen the whole series, love it. Cool. Yeah, I haven't really watched the series yet because it was like one of these things that I wanted to build at some point myself, and then I decided to let's go for it. I could stream this whole thing actually. So. These ones are something else, right? These ones are 0.2 or something. No, that is 0.02 then, by this calculation. 22 and 3 zeros. That's 22 nanofarads then. I had somewhere, like, I think, these blue ones here, like these ones, these are 4 zeros. So this is a 0.1, and I had more of these. The question is just where I put them. But it's also curious that I didn't order them. Let me check in my parts list. I did order apparently 16 0.1. Okay, so that's quite a lot. So there must be somewhere here. Oh, I think I found them. Yeah, there we go. They are like the blue ones, just different color. There we go. Okay, so that means let's go back to, okay, so this was a 0. A 0.1. Oh, sorry. Oh yeah, it has auto range. Yeah, that would be also cool. You have an X tag X. Okay, I put it on a thing. I will check it out and read some reviews about it later. Thanks. Thanks so much. Fluke 18B. I read about that one yesterday. I was researching a bit yesterday, and yeah, it was also a bit annoying how I would buy it. I can get it on AliExpress, but then it takes like ages to arrive here, and you know, I don't know. I guess I could do that. I don't know. Multimeter recommend unit UT. All right, I put it on my list, and then I can watch some YouTube videos and reviews tonight. Okay, so cool. Or maybe we put it, I guess we can. Oh, he did put it one row further down. I didn't realize because of the black and red wires at the top that there's another row. Peak Tech 3340. Thank you. If I understand the 555 formula, for which one? I mean, the one that is connected to pin 5 is just for like, I don't know, to clean it up or stabilize it or something like this. I don't know. Okay, so wait. Ben Eater put it one row down. Okay. I know, I'm sorry, this is super boring, but then I also wanna, then I get also a bit more space up there. F. Okay, so you are talking about the, yeah, but this one, so this one controls that will have effects on the speed of the timer. So that's why we want the exact value, that the speed is like matching to what we want. Come on, go in there. From a scale 1 to 10, how likely is a spark? Well, yes, the thing that is most likely to make a spark is, I guess, the capacitor, the polarized capacitor, which we were successful with not burning it yesterday already. So I'm very confident. There we go. My gosh, that was hard. Guess we can put this down here for now. Then we have the 0 point, this one here, that goes from pin 5 over there. Yeah, into ground. So we take like this. Do you guys hear the kid outside? Okay, like that. Or maybe I should have. No, it's fine. Cool. And then we need, okay, so we got this side done, I think. So on this side, we take the big capacitor. And this one needs to cross over. Okay. By the way, I really like your YouTube videos, but I understand 10% of what you are explaining them, but somewhat I watch some massive interest. That is cool. Thank you so much. And my theory is actually that you probably understand more than you might think. And I also think it's just like, so first of all, that kind of sucks because I feel like then I didn't explain it well enough. But I do hope that it gives you a sense of a feeling of I could totally do that if I wanted to. Like this, I didn't quite get it yet in the video, but I have some pointers where I would get started if I came across this again. So for example, if you would get into security and you would come across something and then you realize, oh wait, didn't liveoverflow make a video about that? Let me rewatch it again. Oh, okay, now I have kind of an idea what to do. Like that would be my goal. That's what I would hope to achieve. And if you have feedback, like if especially if you know a topic, right? And you watch my videos and you think, oh, well, this wasn't explained how I would have explained it. That seems like way too confusing. Doing it like that would have been like way better or something like this. If you have feedback like this, that would be. I have never received such feedback, and I'm not sure why. So if you have thoughts on something like that, I would really welcome that. Okay. Then we need another power. Wait, let's take this one here out for now. Can you help me, because I have my new gaming PC and right now I'm trying to connect to my TV. It has an RGB PC plug and I have plugged in and running it. It's still the same. I have no clue what you're talking about. You have a TV with an RGB PC. I don't know what an RGB PC plug is. I have no clue. Because most of the people watching to me are way less or even no knowledge of every time you say, but look what I found. I'm like, let's see it from second. I have also no clue what an RCA connector is. I watch a lot of Linus Tech Tips, but I still feel like I have no clue about RGB in PCs. And then we have the LED. Oh, wait, is that, how is that called in German? I know what you mean. Is that also what it's called in Germany? RCA? But yeah, then how do you connect that? Then you need like a converter or something like this? And then again, I don't understand how that would have worked with your old PC. Does your graphics card have such a connector? Or I don't understand. Regarding feedback with computers, there are always tons of ways to reach a goal, so there's no reason to say I would have done it different. Yeah, true. I absolutely agree with you that I get sometimes super annoyed at like comments with, oh, why didn't you just do this? Because these comments are stupid, because like, I don't know why it doesn't matter. I did it, like it worked my way. But this is in the case of like CTF videos, or where I describe like my path of how I did that. But so there are like two different kinds of style of videos, right? There are the style of videos where I just tell you how I did it. And then, of course, like if you tell me, why didn't you do this and that? Well, then I can just shrug and I don't know, like maybe I didn't know this, or like it doesn't really matter. I still got the solution. But then there are parts of the video or entire videos where I want to explain a concept. So like my binary exploitation series, this is where I am not really showing you how I do it. This is where I am showing you, where I try to explain it to you. And for these, I'm deliberately thinking about what would be a good way to show it, what would be a good way to visualize it, what would be a good way to approach it, the order of things, right? It's not like a CTF challenge or project you finish and you show which tools you used. At this moment, it's like, how do I decide to show this to somebody? Does that make sense? Don't such comments increase the interaction? Do you mean like in terms for the algorithm, like comments increasing engagement or something like this? Yeah, so a good example is the here at the bottom right, my Raspberry Pi video. I mean, that one like got viral, right? It caught the attention of like weird people, and so people were then like telling me about the Win32 disk imager, which is, or no, different example. They were telling me, why didn't you just plug in a monitor and a keyboard or something like this, and then like, well, if I had a monitor, I might have just plugged it in, but this person didn't have a monitor. Or people were saying, why didn't you just use a Linux machine? Why did you use Windows? Well, it was explained in a video that this person had a Windows machine. Like, what am I gonna do? Like, you do understand that installing a Linux machine now on his MacBook would take way longer than just trying it on his Windows machine, like right now, right? Like, these comments are not helpful. So this is not what I mean. But if a person, so right, this was a story where I was telling my process, right? But then in my videos, like the browser exploitation videos now, the binary exploitation series where I just explain buffer overflows, the web security series, or also, for example, the XSS videos, the Google XSS, where I try to explain a concept. For example, in the case of the Google XSS, I explained the concept of sanitizing HTML and why you have a sanitizer in the client side, in the browser, and not on the server, and why that exists, right? So that's a concept I need to explain, and I need to convey why it is done in that way, right? And so there it would be really good to get feedback on, okay, I think this would have been a better example to explain like a sanitizer or something like this. This would be really helpful because there I actually wanted to explain a concept versus just me showing my path. Does that make sense? Like the difference between me showing my path, like how I solved something, versus me trying to explain a concept. Like these are the two types of videos. Does that make sense? Don't such comments increase the interaction? Maybe. I don't know if it really matters, to be honest. I don't see like a big difference in like videos that receive comments or not. To be honest, at this point, I only think what matters for YouTube algorithm is the click-through rate. So how many people, like if you have a front page of YouTube and your video shows up, what is the percentage of people that click on your video versus all the other videos? And then the retention rate. How long can you keep the person on that video before they go somewhere else? And that also goes into how do you keep them on the video? Like, does your video make them want to watch more, or will they move away and do something else? I think that's the only thing that matters. So you're looking for what was missing in my explanation, what was hard to understand. Yeah, exactly. Like, I'm sure there are a lot of like small details that I could have mentioned, or, you know, for example, if you want to explain a computer, you can do it like bottom up. You can start with the transistors and the chips, and then you build up slowly what a computer works. Or you can do it top down. You can start with, look, here's software, here's a web server, and here is the operating system, and that's running on chips, and you go down, right? These are, for example, two different strategies how you could explain how a computer works. Which one is the right one? I don't know, but I would maybe choose one method to do it, and then I would really appreciate another person saying, look, I think a top-down would have been here better because for these and that reasons, and I would have shown these examples or something like this. Like, that would be really helpful. Lives are a thing now? You mean live streaming? I mean, it's the second live stream I started yesterday. Sorry, okay, we got distracted. Is this done now? I think this is done now, right? I did do a little bit of live streaming last year, web development, and originally I started with live streaming, you know, like 3 years ago. That's why liveoverflow, but I stopped. I try to start again, and I want to build this 8-bit computer, this series that I'm following in the top left corner there. Okay, I think we can plug this in. I think this looks fine. Let's try. Ah, crap, I need to turn this again. There we go. Also, maybe I want to turn down the ampere. I haven't properly. Okay. Uh-oh. Okay, I just noticed that this is definitely the wrong way. This is minus. Oh man. Okay, wrong polarity of this thing here. Let's try again. Okay, so what did I screw up? I mean, no fireworks, but I could have still destroyed it. Nothing feels hot though. Hi, Ednarek. On Twitch, we don't have this weird vague AI algorithm that can screw you over at any moment. Yeah, so luckily, like, that's also one reason why I don't want this to be like my full-time job or anything. Like, it's awesome to build like a little bit of a business around it and, you know, have like the subscription and the ad money, and it's fun and it's an interesting experiment. But oh my gosh, if this would be my actual livelihood, my income, my main income, I would be so stressed out. Like, I wouldn't want to live like be the AI, the YouTube algorithm, my employer, you know, which you can't even talk to. You know, you are just guessing what your boss wants, and if you screw up, he fires you, and he will never tell you exactly what you did wrong. And if you do well, then it's great. I'm so glad that I don't need to care about that really much. Also, for example, I wouldn't do the browser exploitation series, because the browser exploitation series means my views and engagement goes way down because it's like way too technical and stuff like this. But luckily, I don't care that much about it. So, yeah. Okay, so what did I do wrong here? Let's compare this. So pin 1 is connected to ground. I got that. Pin 2 has the capacitor, and I think I got the polarity correct now. Going to up here, going to ground with the side of the capacitor that has like the marking. I mean, his marking is on the other side, but wait, that is weird. I think his capacitor must have a different polarization marking, because that's negative, right? This side here. And so God damn it. Okay. Why is this so hard? Okay, so, and then pin 2 is also connected to pin 6 over here. That looks also correct. Pin 3 is the LED. Yes. And it is connected to where the resistor is. And the resistor value, let's measure, it should be the correct resistor. Let's see if I can measure that in circuit. I'm not sure. Yeah, 200 something, so that should be fine for the LED. That should still glow. Thanks, Bang Pow. Oh my god, I'm a fucking idiot. I removed them earlier. Now that you say this, I remember I removed them. God damn it. There they are again. Good eye, good eye. Thank you so much. Oh man. There's like this saying in like the German, I don't know, I know it from like the hackerspace, like German subculture. Or is it a general expression? I don't know. It is einmal mit Profis, like one time with professionals would be nice. Now it's blinking. Oh my gosh, Bangpo, thanks so much. Now it's also drawing a current. There we go. Now it's blinking. Very fast blinking. And we can slow it way down. That's the slowest blinking. Awesome. The browser exploitation series is awesome. It always looked like black magic before. Well, it's still black magic, believe me, even after having done these videos for me. But yeah, I think so too. I think these are the videos that I want to make, and I wish I had watched myself, you know? Like, it doesn't work too well for YouTube algorithm in that sense, but like I said, I'm glad I don't have to care about it well. And Patreons also make this way easier. You know, like Patreon pays actually now as much as YouTube ad money. So it's a huge chunk. And so those Patreon support, I guess, more of these technical videos or something, I would say. Or I would hope so. And so, yeah, it's nice. It's good. Can't you use the small jumper as used elsewhere to prevent from forgetting them? Yeah, I actually wanted to, like Ben Eater, if you look in his thing, he has like these nice black and red wires just going over the top. I removed my wires here because I also wanted to do that. I've removed them, then I forgot about them. Yeah, I love that shirt. I love it so much that I worry of wearing it too much and destroying it. Okay, cool. Yeah, so this works. Let's not procrastinate. We are already streaming for over 2 hours again, and we haven't actually done the second video yet. So let me quickly build that bridge cable here. This black and white over the black and red one over here, and then we quickly do the debouncing circuit. Does he have a big close-up? Okay. What are the max frequency possible for 5.5? Can it catch 1 megahertz? That's a good question. I have absolutely no clue. Wait, what just happened? Maybe minimum period. Oh, yeah. A lower comparator storage time can be as long as 10 microseconds when pin 2 is driven fully to ground for triggering. This limits the monostable pulse width to 10 microseconds minimum. Delay time reset to output is 0.4 times microseconds. The pin current switch within 30 nanoseconds. The data shown below with time delay of okay. Yeah, okay, so no, this is frequency divider. Okay, wait, that's a different application. Hmm. No, this is just yeah, good question what the shortest is. I don't know. Maybe somebody else can look it up and can tell us where we can find it in the datasheet. That would be cool. But yeah, let me quickly make these cables here. 500 kilohertz to 2 megahertz. As a top thing, like some can get up to 500 and some can even get to 2 megahertz, like depending on the quality or whatever. If you don't know how the timer works, you should watch the first video from Ben Eder's series here. It's really excellent, like showing the schematic from the chip from the inside and explaining exactly how the like walking through an example pulse, how the internal components make this thing create like this square wave. It's really good. Max is 2 megahertz, and you say 500 kilohertz is a start, because it doesn't make sense, because this thing can run at like 7 hertz or something. But yeah, okay, top is up to 2 megahertz. Ah, crap. I'm an idiot again. Okay, for now it's fine. I will fix that later. The problem is that here it's going over the ground, and so I would have to have like an angle like going up and then going down again and stuff like that. Yeah, I'm still in university. I'm actually trying to finish my degree right now. I'm working on my master thesis right now. But I'm a bit of a long-term student at this point, so I'm a bit older than what would be the typical time in university. So are you new in this channel, in like, this is the first time you see this Twitch channel, and so the first time you see me, or do you know my YouTube channel and stuff? And just the first time on Twitch or something, I don't know. I'm asking in case I need to do an introduction or something. First time I think, oh, okay. Okay, so quick introduction. My nickname is liveoverflow. I do mostly YouTube videos on YouTube as liveoverflow about IT security and, yeah, mostly IT security, like hacking and stuff like this. There are like hacking challenges that I make a lot of videos about, trying to do walkthroughs explaining my thought process of solving them or not solving them, and also some tutorials on various topics. So right now we have a series on trying to understand a little bit browser exploitation, which is a super complex topic for me, and so I try to learn some basics and create videos about it. Yeah, and on Twitch I just started streaming. I want to build this 8-bit computer from Ben Eder, if you know his YouTube channel. He has built like this 8-bit computer, and I want to build that as well. As I said, I work also in IT security as a freelancer. That's why I'm so slow with studying. IT security is like my main topic, but as I try to also convey on my channel, IT security and hacking is basically just a way to apply your knowledge that you learn about computers. And so doing programming and also doing electronics is a way to just learn about computers that you can then apply also in a security context. So for me, this is educational, trying to learn more about electronics and at the same time having fun and building like a cool 8-bit nerdy computer thing. So that's what's happening on stream. But it's only the second stream so far. Okay, so this looks nice, I guess. Okay, cool. Now let's build this debouncer circuit. Thanks for the gifted subs, Proker. This is the first time that anybody has gifted subs. Did the alert work? Did an alert pop up? There was an alert. No sound though. Oh, okay. Wait. Yeah, I'm still learning everything. Just set up these alerts and stuff. Yeah, thanks so much. Programming C, it's difficult. I'm not sure what you mean by that because in some sense, C is extremely simple. C only has a few concepts that you need to understand, and they translate very well to assembly. So you have a very good understanding of if you're not like C and assembly kind of go hand in hand, and if you understand these two things, you can debug them. It's very easy to understand. There's really not much magic going on. Pointers might seem weird at the beginning, but if you look and debug assembly for like a little bit, it's so easy. It's so basic to understand. So it's not difficult from that sense, but creating a good application with it that is bug-free, that doesn't have memory corruption issues, that I think is very difficult. So in some sense, programming in C is very difficult, and in some sense, it's very basic. Are you doing physical hacking too at your job, like entering building without permission? No, not at all. I have never done this kind of pen testing. I basically only do like either black box testing against applications, or what I prefer more is like source code audits and looking for vulnerabilities there. I'm also a terrible actor, and I'm extremely nervous in person, and I could never, I don't think I could do that at all. Like going into a building and trying that. Oh my gosh, I would shit my pants. Your Twitch stream was announced on Benny or subreddit? Oh really? Oh wow. Need to check that later. The student finds in. Oh man, you know, that video is just giving me like, on some way it's like awesome that how viral it went and how many people found it and saw the video, which makes me obviously proud because, you know, I spent so much time on it and I think it's a fun video. But then again, it's also a very embarrassing video because I was having did so many mistakes and I decided to leave them in. So that's kind of like, I don't know. Like I met somebody the other day at a conference and he didn't know that I have a YouTube channel and he was checking it out. And then the next day he came again and said, oh, I checked out your YouTube channel. I watched one video, and I asked him, which one did you watch? And then he said the Raspberry Pi video. And then I felt a bit embarrassed. And then I told him, please watch a different video. Okay, button. And then we need another 555. Okay, I guess let's start with pin 1 of the 555. So we need another wire to ground. Okay, that just didn't happen. Ignore that. Thanks for the sub, Frankies. Wow, you're live, even though the email was from yesterday? What do you mean with email? What? You mean, like, no, I was live yesterday and today again. I try to have this now a regular stream. I plan to only stream for like 2 to 3 hours. Or less even preferably, but so far I've been pretty slow. I need some discipline to keep this shorter because I want this to be an ongoing thing. And if I do it too much, then I will not have the time to do it next to work and working on my thesis. But if it's like a little bit of a relaxing thing, once a day or so, or every other day, then I can do it. And so I need to pay attention to that, to not overdo it. Oh, you got a Patreon notification. Well, thanks so much for being a patron. I don't know how many VIPs I can have, but I definitely know that this channel is not very big, so I'm sure I can. Yeah, Toby Plus. I started uploading. I mentioned in the Patreon that I want to upload the archive and stuff on a different thing. I will share. I've uploaded the first stream from yesterday, which is also as a VOD available on Twitch. But I also did like a highlights cut, a 20-minute cut of the video, which I've uploaded, but I haven't shared it yet. I will share that later. But then you don't have to. Then nobody has to watch 3 hours. So pin 2 of the 555 now. It's so warm in here. I'm sweating. I hate Germans for not having AC everywhere. I have an AC unit, but I mentioned earlier that it's just like, you know, like an inefficient unit thing that you have to put like at the window and stuff like this, so it would be super loud. So I would really like a central, like if there were such a thing as central heating in Germany, which is also not the case. Then we could also have like central air conditioning or something like that. Oh my gosh. If I ever have the money to build an apartment or a house or something like that, this is like the biggest thing I will invest in. And then we come to pin 3, which is an LED again. Will you continue working on the website too? Yeah, for sure. I intend to. So my plan is, I'm sure I will intermix like working on that soon again with like this stream format here. There are a few small to-dos, as I mentioned, that a few bugs that I want to fix. And also, like, as I mentioned during those streams, I'm not sure if you were there when I mentioned that, like, what would be also cool would be to watch together IT security videos, and then we can talk about them and discuss them a little bit, and then I can also add them to the website. And so we can, like, go through, like, people can suggest other videos, we can, like, watch them and together, and then, yeah, that kind of stuff. I think that would be cool. Pin 3 now. Goes here. And then we need another, I guess it's the same one that we used up here. Yeah. Your wiring techniques. What did you use for wiring? You weren't here yesterday, right? I mentioned that I ordered these from the US because I couldn't find this kind of rigid or like one core wire that are, you see they are like they're not floppy or anything like that. You know what I mean? I couldn't find them in Germany, so I imported these from the US. I could only find them in different like sizes, and I was not sure if they would work on the breadboard, and this is the size Ben Eder was using. You were using some. Oh, you mean like you used this here? Or what do you mean? Yeah, of course. Like these are not like the nice size, and yeah. That's I figured I need that here for like the long wiring and all that kind of stuff to make it look nice. Okay, so what did I use? Like was that like 200 or something? 200 ohm? I think so. Something made a weird sound I've never heard before. What was that? Here, I bought a phone for testing, like mobile testing for work, the Pixel 3a. And it made a weird notification sound I've never heard before because I just got it. When I started the project, Benita didn't have any partners on the website. I think it hadn't a website at all at this point. Yeah, that makes sense. That makes sense. It took him quite a while. I'm not even sure. Did he finish it now completely? Like, is the C series completely done? But it also took him like 2 years or something. Yeah, if you followed along like early on and stuff, I can imagine that must have been a bit harder. There we go. That is all right. And then we have pin 5. Does he connect pin 5? No, pin 5 is not connected. We will check the schematic also in a second if you did like any modification or something in it. And then 6 and 7 has one single unit up. I need to get this with the camera differently. Like I want to show what I'm doing here, but I forget always that I need to be over here and not here. Okay, there we go. And then I guess this is also again one 100k ohm. No, another 100k. 10k. No, wait. Let's check the schematic. So, oh, 1 meg. Yeah, it was 1 meg at pin. So that would be, oops. Pin 5, 6, pin 7. Yeah, pin 7. Oh no, so it's, wait, what? No, wrong here, over here. Pin 7 is connected with a 1 meg to R4, to VCC. So 1 meg over here. Heck, did I not open this before? Yeah, 25. Yeah, I thought about that, trying that out, but I was not sure. Wait, 26, is that smaller? Is it thinner? Yeah, so I was not sure about this. I tried to like look through some forums with like breadboard, wire, AWG, and seeing if I can find any discussion about this, if anybody shares like some experience, but I couldn't find anything. It's way thinner. Yeah, so I think it's like for doing some wiring on like a PCB or something, but not really for pushing it with breadboard. I ranted about this yesterday already. I cannot comprehend how this is, how I cannot find this in Germany easily. This seems like, wouldn't anybody who does anything with electronics on a breadboard wouldn't want something like this? Like, is there something I'm completely overlooking here, and how people solve this problem differently? Like, I don't understand. Is this really our only choice that we have, these overpriced pre-made ones? And jumper wires, you are right. I completely forgot about that. Yeah, of course, jumper wires. But then again, it looks all shitty. But yeah, you are right. That makes sense. Jumper wires, yeah. Okay, 1 meg. Shenzhen style market in Germany. Yeah, unfortunately stuff like this would never be possible here. Maybe I need to rearrange my whole desk thing. I was thinking, like, you see over here the white table where this laptop is laying. So I thought about like moving this whole, like this setup here over there. Wait, how would this look like if I would like work like here? Then you can see my hunchback. I'm not sure if I want that. But then I could maybe also move the camera like over here in that corner maybe. But then you see that part of the room, which looks crap. Oh man, everything sucks. What do you think about the new AMD processor coming out? I have absolutely zero clue what it is about. I know nothing about computers. I'm a person who buys MacBooks. Okay, that should tell you everything. Okay, we need another black connection to ground for the button here. Dirty MacBook user. Look, there's a second one right here. Right here. But for my defense, like on the stream, the computer screen you are seeing is coming here from my Linux laptop. The ThinkPad. Okay, and then we need the capacitor. Which value does the capacitor have? So why are here two capacitors listed? So at pin 6 is this one here, which is a 0.1 microfarad. So this was oh, here. Wait. Oh, funnel. Okay, I need to check that out. So I ended up ordering from Mausers. Where's funnel based? Are they delivering from Germany, or is that also imported? I don't actually know. Oh yeah, I remember. Sorry, I always procrastinate responding to stuff like that. Yeah, sure, I would be interested to come on. And sometimes I also have very fucked up time zone things, so 4 a.m. might even be doable for me. Okay, so wait. So look at this schematic here in the middle. There's a 0.1 microfarad going from pin 6 to pin 6 through the, wait, I'm so confused. Oh, pin 6 is connected to ground. Wait, I'm so confused by this schematic. So on here it says pin 6 is connected to 7. Yeah, that we have that. Okay, so pin 6 and 7 are connected. We got that. And then 7 has a 1 meg going to VCC. And then 6 has on the other side, so 0.1 microfarad going to ground. Is that what he did here? Oh, I'm such an idiot. Yes, he did that. Okay. Ah, I cut this badly. So you're building the clock generator right now, but what is the reason for the second I see in the middle with the push button? Okay, so right, so this was in the first video we used the first chip up here to create basically a clock signal that we can adjust the speed with the potentiometer. And now the second one, as far as I understand, is we also want a button as a clock, so that we can, for debugging reasons or so, have like single clock clicks forward instead of the auto clock. And to implement the clock like this, we have the bouncing issue of the thing. So the second one is also 555 that we use as a debouncer. That is the topic of the second video. We will check this out with the oscilloscope in a second. As soon as we have assembled this, we connect this to the oscilloscope and have a look at and replicate what Ben Eater did. Okay, so now he also has in the schematic on pin 5 a 0.01 microfarad connected, which we also have done previously on the other one. So let's do this as well. So put that in here, and that also goes to ground. Yes. I tried this a few years ago. It was very fun, but I could only get to 7 bits. What do you mean by that? You only could get to 7 bits? I don't know, maybe that makes more sense this as soon as I'm further into the series. Is that a thing like that you build like bit by bit something, like the bus or something? I don't know. So I don't understand quite yet. But yeah, I hope that through the pressure of the stream I will have the motivation or the pressure to also finish this, because I think it's a cool thing. It's quite an elegant way to debounce a button. Well, I don't know if it's an elegant way, but I think it's an interesting way. Like, I think showing off the 555 timer in a different application that is different to the regular timer or something like this seems interesting to learn. And so I also encourage you to rewatch the Ben Eater videos, because he explains based on the internal circuit of the 555 why this debouncing works, or how the internal circuit works. So that's super interesting. That really gives a good understanding of how this works. Okay, so did we finish this now? I think so. Let's compare really quick visually. We have the LD, we have this connection. Oh no, we miss a resistor at the bottom button. Is that the pull-up resistor? Yeah, that should be the pull-up resistor. That was 1K, I think. 1K pull-up resistor. Check the schematic. At the switch, we have a 1K pull-up resistor. Okay. Let me be honest with you. I don't understand pull-up resistors and pull-down resistors. I do, so I kind of know that you like where you place them, but I don't really get it. If anybody has like, and I have read a lot of like Wikipedia and Stack Exchange, it hasn't clicked for me yet what it means. If you think you have a good resource, a good concise like video or article that explains not only like where you place them, but why you place them there, because I feel like I don't know, there's something missing for me that it hasn't clicked yet what they are for. Like why you don't connect them directly? Why do you need the resistor? What and what's the, why does it have to be like 1K? Why is it not more or less? Kind of thing. I guess I understand, because if you just use a wire, you have a direct connection. But what is special with the resistor that it doesn't cause a short and it burns through? I don't know. You know. It's overkill method to debounce a button. Imagine you have a keyboard. Yeah, for sure. I mean, that's true. Wait, this goes to like that. Okay, now I think we got it. So, do we feel brave? Are we plugging it in? Okay, we definitely screwed something up because it's not blinking. Oh wait, oops, I'm an idiot. I connected the oscilloscope. Now it's blinking again. Cool. Okay, so now it's blinking. Now let's press the button. Okay, when you press it, it turns on. Okay, so now let's look at this in the oscilloscope, and then we can also soon wrap up this stream. Oh, sorry, there were a few more comments. Now I know what to do with the whole box of 555 ordered from China some years ago. Toby, you should search on Google for 555 competition. There's like this, like a while back, some people made like a competition of using the 555, like building circuits only with the 555. Like that's the only allowed chip, and then what they can come up with. That's super funny. It's too a non-connected wire that can have some voltage from static electricity. Yeah, but like if you look at the connection, it's like a resistor directly between, for example, ground and VCC then at that point, right? Or not? I don't know. Yeah, okay, so maybe that's the problem I have. The resistor value isn't that important. It's just to prevent having a short circuit. And that's what I don't understand, because every wire has a resistance. So, I mean, it might have like 0.1 ohm or something like this, right? It might, or 1 ohm or whatever, it might be super small. But everything has a resistance. So, at one point, and where is that point? Does it go from a damaging short circuit to like not damaging? And why do we usually use like 1K? Why do we not just say any resistor over 500 ohm or something like this works? Like, pull up and pull down resistors are used like weak logic values just to get the current range. The resistor is set to 1K ohm because it's about 5 milliampere you use. Okay, wait, so the formula was I equals to U divided by resistance. Okay, I still don't get the significance of that. Okay, cool. So let's connect this one here directly to the button, so we can like record the bouncing, and then also to the output of the, to see like the debounced value basically. So wait, this is ground and this is ground and this is high. Great. And then use this one here. With a near zero ohm resistor, you will get nearly infinite current consumption. So if you have, right, so if the in that formula, I equals to voltage divided by resistance, if it's the smaller it is, the larger the value gets. Okay, that makes sense. Okay, yeah, okay, okay. Okay, now I think I get it. Now looking at this formula again, like I equals something, and then the resistor value, if the smaller it gets, the higher the current will be, and that's a problem. So you can limit the current flow. Yeah, and based on, because we often work with 5 volt, that's why like 1K is like a good reasonable amount. But theoretically we could also, and we don't go too high, because does it matter if we go like, does it matter if we go like 1 meg ohm? Would that be a problem? And the output is here. Okay. Cool. So let's see. Let me bring that maybe a bit closer. Okay, so I connected the probes to directly to the button, so we should be able to. What did I do? Something is broken. Oh fuck! I had a short circuit. Okay, still seems to work. One of the pins touched, so the ground rail here touched the VCC, and you maybe heard the relay clicking of the power supply, cutting off the power because of the short circuit. Oh my god. Okay, so. Okay, so let's set the trigger here, and let's trigger on the pull the output of the 555. Now wait, we can. Well, let's trigger on the button. We trigger on the slope up. And we want, let's try a single one. Oh wait, can I set the hold off time somewhere? Okay, let's see if that works. Okay, so this is just single. Let's change. Okay, cool. Okay, so wait, let me think. So yellow is the output of the button. No, wait, that's not true. Wait. I need the other way slope because we have a pull. So we want to catch. It's a pull up resistor. So we want when we click, it drops down to ground. Wait, oh my gosh, trial and error. Yeah, okay, so I think now it's correct, right? Wait, let me zoom out, we will see that. There we go. Okay, so we can see here, yellow is the state of the button. It's high all the time, and when we press, it drops down to 0, and when we release it, it goes up again. When we try to press like super short, we see that it drops down the press, and then I release, and it goes back up, and then so now the button is up again. And blue is the output of the 555. So you can see that the 555 then kept it longer on and then went down. And blue will always be consistently the same length, except we keep the button pressed longer, of course. So no matter how short we press, the output of the 555 will always be that high. See that? Always be the same length, no matter how long we like press the button, except obviously when we keep a bit longer pressed, then the whole thing will be extended. Okay, so the reason why we do this is for the debouncing. Ben either explained that in his video, but if you joined later, I show you what bouncing means. If we zoom in a lot on when we press the button, so you see here kind of also the delay. Like here, this is when we press the button, and then it takes a moment for the 555 to like trigger on that. Okay, this might have been like a bounce. Maybe I need to zoom out a little bit more. That could look, that bounce. That's maybe a triggering issue here. Maybe the bounce is. Here you can kind of see it bouncing a bit. The trigger is just too fast again. Like I think it triggers on like weird values. Like this is like this was bouncing here. Look, it triggered, like it was down. This is when we pressed, and this was when it was coming back up again. It like bounced there once, and then it triggered on that. Maybe we do the single trigger, and then I just need to yeah, you can kind of see the bouncing, right? Like if it would be like a perfect button, it might just be like, you know, going down, but it doesn't. It like has like weird crap from the context, just like the metal contact. Come on, bounce for me. Okay, well, this is a great demo. There we go. That's, I think, a pretty good bounce. So it went down and then went up again, and then finally it went down. And because of like, it just, you know, the N55 registers like fairly slowly. So something like this could be, you know, causing a, if we had the whole CPU and this is how a single clock pulse would look like, that could maybe cause, you know, issues with some calculations, because some components might register. Oh, look at this. That was a perfect bounce. It went down once, it came back up, and then bam, it went down again, and only then finally the 5.5 was coming. I mean, it was too short, this bounce, for the 5.5 to trigger there already, I guess. There's some bouncing happened before again. Yeah, maybe that was... Here, look at this. This is also a nice bouncing, I guess, showing like how this flakes. Oh yeah, this was great. Okay, now I didn't record much, but yeah, you can see like how crazy like it might bounce sometimes around. Let me read the stuff you wrote. So the pull resist current. Anyway, the higher the pull-up gets, the slower the voltage level would change when the switch component does not conduct. Okay, I guess, I don't know. Don't quite get it. When you stop pressing the button, it also bounces. Yeah, okay. Yeah, I think we dealt with that. Do you have a capacitor near the button? Were you wondering just because we didn't see a lot of bouncing or what? Yes, kind of. I mean, there are some capacitors on the power rail, like over here. So it's not like close to the button, but it certainly, I don't know if it affects stuff. Cool. Awesome. Was there anything else you would like to see measured? I'm not sure if I forgot something there now that we should do before I end the stream. Because, okay, so I would end it in the next 10 minutes or so. So let's, I think, right, I finished that video. Oh, was there anything else in the video? No, he was showing just the... Yeah, should be fine. Yeah, cool. I think that was pretty good success again for today. There you go. Automatic wire stripper. I will check that out. I thought I wanted to buy a good a nice wire stripper too, but I didn't exactly know. Is that a good one? I looked at them and they looked weird. I thought maybe they were gimmicky, but are they good for like small? Oh yeah, they are for 24 to 10. Well, I have 22. But should still be fine maybe. Yeah, I will look around for one again. Which software would you recommend for PCB design? Unfortunately, I've never really done any PCB design. I only used Eagle like once to create like one PCB in my life where somebody helped me. Was also nothing special, just some shift registers and LEDs. Oh, Carbon, you can also recommend them? Okay, awesome. Then I might order one of these too. You could also add a Schmidt trigger after the output to clean up the created pulse. Well, that goes on the, I need to Google that list. Well, I'm also curious what Ben Eater will does next with this circuit, because somehow we need to like combine them, I guess, somehow. The regular clock pulse and the button now. And if we checked like, you know, that module later in life, so there's another button. I think that's a switch that might be used to switch between these two ones, I think, maybe. You can select if you want the button press clock or if you want the auto-generated clock. That's my assumption. And then I don't have no clue what these are over here. But yeah, we will figure that out in the next few streams. Yeah, just as a quick recap, we finished the second video of Ben Eater's series on building an 8-bit computer. You can see it blinking still over here in the button press. We replicated the test Ben Eater did with the oscilloscope as well. The stream is being recorded and should be available as a VOD on Twitch for as long as Twitch keeps it there, and it will also be made available on a YouTube channel where we'll upload it. I will still need to work on that YouTube channel. I will share it on Twitter, probably once I can share it. Yeah, so follow me on Twitter if you want to stay updated. Follow on Twitch, and you know, check out my YouTube channel, liveoverflow, as well. Yeah, that's all. Any remaining questions? Otherwise, I would head into the. I would stop the stream soon. I recommend Knipex. Okay, I put it on. Do you know? Yeah, I read the name, I think, somewhere, but I have no clue. I wrote down the Knipex as well. Okay. Then thanks so much for hanging out with me today. And I see you most likely sometime tomorrow. I don't know exactly the times yet. Sometime. Oh, my emote got approved. You are the first person to. I didn't even try out this emote because it wasn't approved yet. Oh shit, I did it wrong. Oh, I can't do it myself because I'm not subscribed to myself? It's just, I think the integration. Oh, it works on your screen? Oh, it did. Yeah, you're right. It also worked on the stream. It didn't work in the OBS Twitch integration thingy. Okay, all right. Nice, cool. Let me know if you have ideas for any other emotes that I could add. Okay, awesome. Cool. Again, thanks so much for hanging out. See you probably tomorrow. I don't know the time yet. So keep a follow here and, you know, enable the email, I guess, or whatever, or watch the VOD. Yeah. Bye-bye.